Let's solve some problems based on the voltage divider. Here in this problem it says in the circuit shown below, voltmeter V2 reads 24 volt. What is the reading on voltmeter V1? So if you look at the diagram carefully, there are two resistors. One is 30 ohm and one is 60 ohm. Let's name them as R1 and R2 because they have named it as the voltage, they have named it as V1 and V2. So they give us V2 as 24 volt. That means R2 will be 60 ohms. V1 we don't know, we want to find, but we know what is R1, which is 30 ohms. Now the circuit which is given to us is a series circuit, and in series circuit the current remains same. So I can find the current using the values for the second resistor. So I'm going to use I equal V over R. V will be 24 and R will be 60. We get the answer for the current as 0.4 ampere. Now because it's the series circuit, the current will be same. So I can use the same current for the first resistor also. So I can use the formula V1 equal I R1, where I will be 0.4, same current, times 30, and I get the answer as 12 volt. Next we have a problem on Kirchhoff's junction rule. Junction rule says that the total current entering the junction P should be equal to the total current leaving the junction. So we can see that there is a junction P where the currents are entering and leaving. So Kirchhoff's junction rule says that total current entering should be equal to total current leaving. Also remember that Kirchhoff's junction rule is based on conservation of charge. So I'll just write it on top. So what rule we are using? We are using Kirchhoff's junction rule, and sometimes they ask you what conservation rule is, conservation law is applied here. It's based on conservation of charge. Okay. Now we want to find what's the total current entering and total current leaving for the diagram which is given to us. We can see 3 and 4 ampere. Look at the arrow. It's towards P. That means these are the currents which are entering. So that's 7 ampere entering. Now if you look at 4 ampere and 2 ampere, the arrow is going outwards. That means these are the currents which are leaving the junction. And if we add it up, we get that as 10 ampere. So according to Kirchhoff's junction rule, the entering current, the total current entering should be equal to total current leaving. That means this ammeter should read 10 minus 7, which is equal to 3 ampere. That means the ammeter reading should be 3 ampere and it should be entering the junction. Okay, in this next problem, we are going to apply Ohm's law and find out the different things which they are asking us. So first thing it's asking us, find the reading on the ammeter. So we have been given a diagram. There is a cell or a battery which is of 60 volt. There is one resistor which is 20 ohm. There is an ammeter connected. We can see that it's connected in series. And there is a voltmeter connected which is connected in parallel. So reading on the ammeter reads current. So we want to find what's the current reading. Current I is equal to V over R. Voltage is 60. Resistance is 20. We substitute that. We get the answer as 3 ampere. Next question is asking you calculate the power delivered to the resistor. Now power, the formula is VI. There are 3 different formulas for power, but we can use VI. Because we know what's the voltage and what's the current. Voltage is 60, current is 3, so we get the answer as 180 watts. Then we want to find out what's the energy delivered to the resistor in 10 seconds. Energy formula is P times T. Power we already calculated in part B, so the same answer we'll use here, 180 times 10. Time is given in seconds, so we don't have to do any conversion. We can just directly use it. And the answer comes out as 1800 joules. Next, 3 resistors are connected to a battery as shown in the figure below. We can see that it's a series circuit. It's asking us to calculate what's the equivalent resistance. That means the total resistance. Formula is R1 plus R2 plus R3. We add up all the three resistor values, we get the answer as 18 ohms. Then it's asking us to find the total current in the circuit. We know that I is equal to V over R. In this case, we are going to write V over R total because it's a series circuit. The current will remain the same. So we have to take all the resistors into consideration. So the value for V is 36, R total is 18, and we get the answer as 2 ampere. Now in case if the question had asked you what's the current through R1 or what's the current through R2 or what's the current through R3, the answer will still be 2 ampere because the current in a series circuit remains the same. So when you calculate the total current, you need to use the battery voltage divided by the total resistance and you get the current, which is 2 ampere in this case. Next we have got a parallel circuit. We can see the diagram. The current is splitting into 3 parts. That means it's a parallel circuit. Formula for equivalent resistance for a parallel circuit is 1 over R total equal 1 over R1 plus 1 over R2 plus 1 over R3. We substitute the numbers, use our calculator, and we get the answer as 1 over 2. But remember, this is 1 over R total, so we need to flip the answer. So our R total will be 2 ohms. That's our final answer. So in parallel circuit, do not forget to flip your answer, which you get from the formula. It's asking then to find the current through 4 ohm resistor. Now in parallel circuit, the voltage remains the same. So if we have 24 volt battery, for each resistor the voltage will be 24 volt. But each one will have a different current. That's why you can see it is written I1, I2 and I3. We want to find what is I1. So we'll write V over R1. V, that is the voltage of the battery, which is 24, over R1 is 4. We get the answer as 6 ampere. Now if they had asked us to find the total current in the circuit, then we have to do V over R total. And in this case, in a parallel circuit, the total current will be different from the current which is flowing through each resistor. So I1, I2 and I3, they will all be having different values, and when you add up I1 plus I2 plus I3, you will get I total. But if you remember in the previous question, we said in series the current remains the same. So whatever you have the total current found for the circuit, that's the current which is flowing for each resistor. So remember this part, how the current in series remains same and in parallel the current will be different.